So we're in 4.1 now.
The chapter on classroom.
I have not posted this yet on Classroom. I got it's just been kind of everything's been late this morning.
Are you actually?
Okay, so please do not look in your book for this. Your book will throw you for a loop. So this is completely notes-based. Your homework's going to be AP problems, free responses. You're going to start getting some practice there. Every single one of these slides is an AP problem on it. All right? So here's the big idea about linear approximations. Okay, so there's a graph of a function, right?
Yep.
If I asked you, let's just do this. There's the function, right? What is f at 4? 16, right? Okay. You know that's fact. Linear approximations use the derivative to approximate that value. Okay? So basically, we would say calculate the equation of a tangent line at 3. Right? What's the equation of the tangent line at 3? Right. The derivative is 2x at 3. That's 2 times 3 is 6, right? X value and then your y value. What we're going to do now is approximate. It would say approximate f at 4 with the equation of the tangent line at x equals 3. So plug 4 into the equation of the tangent line, right? No. Are you with me? I know I'm writing furiously. I'm in a hurry and I don't need to be, so. Okay, so we're going to approximate with the tangent line. All right, so plug 4 in. $12 plus 9 is?
No.
Sorry.
Well, 9 is 3.
There we go.
So
6.
6 plus 9 is 15.
Okay. It's close, right? Yeah, so you can see that there's you can compare those two values as very close.
So would you not need to use the about equal signs to do the same with the equation of the tangent line?
No, do not, because this is equal to the, right?
Yeah.
So you are giving the exact answer they're looking for. But, so that's the idea here, right? This is a simple example because it's an easy function. We use this a lot more with more complicated functions because their values are harder to obtain. Or we use it where we have a derivative only and we don't have the original, like in an implicit differentiation. They give you the slope, like dy dx equals. Okay. So this is the big idea. Are you all right? Because you can calculate derivatives and tangent line equations, right? I hope. Okay. All right, here's an AP problem. Hope. Okay, it's from 2013. Okay, it's number 6, so this would be the last question on the exam. Okay, consider this differential. dy dx equals e to the y. Well, let's just check. Oop, wrong one. Leave that. Oh, that's lovely. I think it's a y. Okay. Times 3x squared minus 6x. This, let y equals f of x be the particular solution to the differential that passes through 1, 0. There's your point. Okay. This you will understand later in the year. This is the last thing we do. It's called differentials. We will actually calculate the y equals equation from the derivative. We go backwards. Okay. But part A, write an equation for the tangent line to the graph of f at point 1, 0. Use the tangent line to approximate f at 1.2. Okay. So at this point, we're writing the equation of a tangent line, right? Fill in the blank. What's my y value? 0. What's the x? 1. All we need to do is find the slope. Yeah. It's, the nice thing about these is you're given the derivative. You can't screw it up. Right? Plug 1, 0 in. So dy dx at 1, 0. This is your notation. E to the 0, 3 times 1 squared minus 6 times 1. So what's our derivative? Right. Okay, there's a point, probably a 2-pointer on this one. That steps. Okay, part B on this question on the actual exam is worth 6 points. All right, so how do I approximate? Yep. Stop.
Huh?
It's a free response. Is that a numeric answer? Done? Done. D-U-N. Done. Not adding and subtracting is more F-U-N. Fun, right? So, now could you finish this problem? Yeah, you could. I mean, 0.2 times -3, -0.6. No. It's like trying to teach an old dog new tricks. I know it's habit to simplify, but think through the free responses and don't. Okay? Montaigne lost a point on the exam on last week because of that right there. Okay. All right. Are you okay with that process? Equation of a tangent line? Plug it in. All right. Here's another one.
Let's get progressively harder.
It's got a cosine in it this time.
Oh.
Okay. Consider this differential. You're given another slope, right? Or you're given the derivative already. Let y equals f of x be the particular solution to the differential equation with the initial condition. The function is defined for real numbers. What point is that?
0, 1.
Yeah, so keep in mind we can make statements like that. Write an equation for the tangent line to the solution curve in part A at the point 0, 1. Use the equation to approximate f at 1.2.
Y minus 1 equals length.
So go ahead and do this. Keeping in mind on these free responses, it's a very good skill to annotate like I did. You could even say, slope, yay. I know you don't have sticky notes, but if you annotate these like I did here, you're putting those things in your brain and making these problems simple. Okay? All right, give it a shot. And then we'll go over it. And do I need to sit down? Should anyone help? And this is no calculator, by the way. It's number 6.
This is a calculator. What is A?
A on this was a slope field. You have no idea what that is yet.
Oh, so it like it didn't exist, like you took that off.
I took A out.
Okay, I was like.
This
what?
is part B.
That makes
Part
sense.
A was the easiest free response I've seen on a calculus test, actually.
This one?
No. A and B on these were super easy. Okay. Hunter. dy dx evaluated at 0, 1 is what?
Cosine of 0 is 1.
Oh, cosine of 0 is 1?
Yep.
Then it's 2.
Okay, so anybody would volunteer the equation that's not Damon? Shannon?
What? Y minus 1 equals 2x.
Yeah, you don't have to put the 0, right? But you can. All right, so you've just earned a couple points. What do we do next, Garrett?
Plug in, that 0.2, 0.2?
Yeah, 0.2.
Yeah, so plug that in for that.
0. I thought that was 0.
And then,
Can I be done yet?
you have, I feel like you have to move that one.
You do have to move the 1. But again, no touching, and you're done. Okay. So. All right, so those are the calculation style. They show up probably, I'd say once every other year. These problems show up on the free response.
So we just have last
Is it an off year?
That's the question, because they did 2 in a row this time, 13 and 14. I don't remember one on 15 or 16, so you never know. It could show up, just be ready. All right. This is a good problem for us to start going over because they're contextual problems and stuff you're going to see. This is number 1, therefore it's 2014 again. Okay. It's calculator friendly, so you're going to see a function that's an exponential that you could do by hand, but you don't need to. I will show you how to do those on the calculator once I'm comfortable with your by hand skills. Grass clippings are placed in a bin where they decompose. Ooh. For 0 to 30, that's the time, x values. The amount of grass clippings remaining in the bin is modeled by this function, where A of t is measured in pounds and T is measured in days. Pounds, days. Okay, so you can do A. Find the average rate of change of A of T over the interval 0 to 30 and indicate units of measure. What's the average rate of change formula? Yeah. The y values over the x values. Now, fortunately, you get a calculator for that, and you can do the values and get a number. What are the units? I will give you pounds what? Per day.
Oh.
It's a rate,
Yeah.
right? So rate of change must be a rate, something over time. Okay. 2 points right there. Right. Okay, part B we can also do. A prime at 15, right? So, A prime at T is constant. What's the derivative of 0.931 to the T? It's an exponential.
Log of
Yeah.
0.931 times 9.31 to the T.
You got it. Natural log 0.931. 0.931 to the T. Right? You didn't even need the calculator. The nice thing is, your calculator, if you enter this in the calculator, there's a derivative function. You put derivative at 15, it will spit the answer out. Right? Again, I'll show you that. And then A prime at 15 is and you're done, right? You got the credit. So we haven't even used a calculator yet. We got most of the points.
Why do we use a natural log?
The derivative of, remember if I have y equals 2 to the x, what's the derivative? It's ln 2 times 2 to the x, right? So this is an exponential. You take the natural log of the number times copy what was there. Right, good? Okay, good question. All right, so we can do A and we can do B. What, using correct units, interpret the meaning of the value in context of the problem. Ooh.
Grass clippings decomposed per day.
It's a derivative.
How many grass clippings are?
So yeah, you're right. This is the amount of grass clipping, or the rate at which clippings decompose in pounds per day, right?
Now would that be the way you have to say it?
Yeah, and you probably want to use the word increasing or decreasing as well, depending on positive or negative. So grass clippings decompose at
Well, I guess
a decreasing rate. Okay. We'll get more into that later, but just thinking through, right? C we have not done yet, so we're going to skip it. But part D is the linear approximation. Okay, for the time greater than 30, L of t, the linear approximation to A at t equals 30, equation of a tangent line, right, is better model for the amount of grass clippings remaining in the bin use L of t to predict the time at which there will be 0.5 pounds of grass clippings remaining in the bin. Show the work that leads to your answer. All right. So, linear approximation. X is 30, right? How am I going to find Y? Plug it in. Right, so does anybody have that handy?
6.687. Oh, not a
Times 0.931 to the 30th.
Yeah. I had that for after.
Anybody else? You typed it in wrong, dude.
Did I?
Yep. 0.931. Okay, 0.782. And then I'm gonna math this up. Oops, that's what I want to say. Math. That's negative 0.055. Good tool, right? That's fine. Okay, so, sorry, my equation's kind of messy. Do you want me to rewrite it?
Please.
Y minus 0.782 equals negative 0.055 x minus 30. And then, okay, here's the difference between what we've been doing. Use L of t to predict the time at which there will be 0.5 pounds of grass clippings remaining. Where do I plug that in?
Oh, why?
Yeah, that's a y value.
Yeah.
It's not a time, right? So we have to put 0.5 here. And solve for x. Okay.
Divide by 30.
Yeah, so divide by negative 0.055, add 30, leave it alone.
So don't try to do the math?
No, you don't need to. Solve for x, let it be.
So you get the 0.5 minus 0.782 over the negative, so, and then that would be in parentheses, and then you'd
Add 30. Yeah, it's going to be, okay. All right, so again, straightforward, write the equation of the tangent line and calculate the value. Good? Okay. I have not posted these, 'cause I ran short on time, so, but they are AP problems. So your homework is 2011, number 5, A and B. 2010, number 6, A and B. These are no calculator. 2013, 1A, calculator okay. Right? So we're going to start seeing more free responses. You'll get a lot better at them. And again, I'll post those next hour. Sorry. It's got too much to do this morning.
I feel that. It's okay.
Stayed up too late. Yeah. Spent 8 hours smoking sausage last night. It didn't
I thought you were gonna say something else. I was like, wow, we really have fun too, haven't we?
I drive through Quebec every night. It's great. I'll never stop here because I don't want to be seen. But yeah, no sausage, really good food.
Oh, we gotta start hearing.
You can, if you want, look these up online right now. Just type in calculus 2011 number 5. And it should bring it up as a PDF. Or calculus FRQ 2011. Okay.